Okay, so we talked about transformations before. We're going to continue talking about them. We're going to focus on compositions of transformations today. Compositions of transformations look something like this. You can relate them back to Algebra 1 if you remember seeing something that looks like f of g of x. That's a composition of functions. But now we're going to talk about compositions of transformations. So now instead of it being written how I just showed you, you could also have a composition of a function written like this. F O G is how you would read that. But now, with transformations, we're still using that circle symbol that you used in the FOG. When we have compositions of functions, you're always going to start on the right-hand side. So you would do this transformation first, and then after you're done that transformation, you would go over here and do that one. So before when we had a point, if we had point A, after the transformation it became A prime. But now since we're doing another transformation, we're going to have an A double prime, or whatever the letter may be. Okay, so this is our composition of transformations. I'm starting with the point 2, 3. That's the point I'm going to plot. I'm going to call that A. Now the first transformation I'm going to do is I'm going to rotate 90 degrees around the origin. Remember, if it's not written, and then it's assumed that it's counterclockwise. So when we rotate 90 degrees counterclockwise, we can take the image and turn it a quarter turn to the left. So when I turn 90 degrees counterclockwise, I would write that new coordinate down as A prime, so that's -3, +2. And then rotate my picture back to its original direction. So our A prime is at -3, 2 after I rotate it 90 degrees counterclockwise. So that's A prime. Now our second transformation, going to the one on the left, that's our second. We're going to reflect across the y-axis. So here's our line of reflection. This is 1, 2, 3 away from that line of reflection, so I'm going to go 3 on the other side. And that point will be a double prime. So my final answer, the composition of that transformation, will be 3, 2. So A double prime is at the point 3, 2. So let's look at another example. So this composition of transformations is using the point 0, 2, so we want to call that A, would be at that point. And the first thing that I'm going to do is reflect across the line x equals -2. So like I showed you before, if you're not sure where the line x equals -2 will be, make a couple points where all of your x values are -2. You can put whatever you want for the y. And when you plot them, it should create the line for you. So this is the line x equals -2. So that is the first transformation I'm going to do, starting on the right-hand side. reflect across the line, x equals -2. So I'm 2 units away, so I'm going to go 2 on the other side. So that point is my A double prime. So the second part of the transformation was to rotate 90 degrees counterclockwise. So I rotated my picture 90 degrees to the left, so a quarter turn. And now I want to look and see where my A prime point was. Wherever my A prime is will become my new A double prime. So this is the point that I'm looking at, and that looks like it is at -2, -4. So now I can rotate the picture back and then plot my final A double prime point. So my A double prime is at -2, -4. So that would be my final answer. So we go from A, and then we go to A prime, and then we move A prime to A double prime. So A double prime is at -2, -4. And that would be your final answer.